Welcome back everyone, Mr. Allen here. We're going to go over sketching rational functions today, sort of the simplest of rational functions, the ones of this form, and we'll use this 6x minus 9 divided by x plus 3 as our sample question. So recently we've kind of looked at a few different features of rational functions and of functions in general, how to find the x-intercept, the y-intercept, and vertical and horizontal asymptotes. Those are the things we know how to do, and using those we can get a very good sketch. Now again, the word sketch here, it's not really a graph at this point, but it's a sketch of what the graph is going to look like. And so starting just kind of in order here, for the x-intercept we set y to 0, and literally we can just kind of write that out if we need to. Y is 0 here. Solving this, we find that x is 3/2. So that's to say that the x-intercept on our graph, so x-intercept, we got 1, 2, so 3/2 would be right in here. Right about there. And now all it's doing is giving us a point of reference that once we're ready to actually draw our lines in, we can make sure we hit. So x-intercept out of the way, and the y-intercept then, and of course the y-intercept will be the opposite of what the x-intercept was. The y-intercept occurs when x is 0. And so again, literally we can just plug that 0 in. The x-intercept, sorry, the y-intercept x equals 0, put the 0 in, we have 9 divided by 3 is 3. And so again, very simply, 1, 2, 3, this is a point that we will make sure we hit as we go through. I'm going to pull the x-intercept back because I did intend to say something here that I forgot. I'm not one to sort of say I like to I'm not one to like rules, and a lot of people will often say to solve for the x-intercept we solve for the numerator, or we solve the numerator equals 0. But the reason for that, if we just sort of think about the basic question here, I put the 0 in for y, and then if I did try to solve this by sort of conventional means, my first step would be to multiply both sides by x plus 3. And of course, if I multiply the left side by x plus 3, I get 0 times x plus 3, which is just 0. And so I end up with 0 equals 6x minus 9. Okay, so just sort of, if I skipped that too, I went through that too quickly, I just wanted to clarify. In this case, only the numerator can be 0 in order to get a 0 here. And so that's why the denominator basically disappears during our calculation. So now both of those should be fairly easy, I hope. We've certainly done them for, or you've done them for years and years. The vertical asymptotes, remembering that the vertical asymptote occurs when we get division by 0. So it's a spot on our graph that we cannot hit because it gives an impossible calculation on the calculator. So that's to say that x plus 3 would be 0, so the denominator would be 0. And of course that makes for a pretty easy calculation as well. When x plus 3 is 0, x is negative 3. And so we can just basically draw in that line at x equals negative 3. Once we know the location of our asymptote, there is a bit more work to do, of course. And essentially, I'm trying to figure out whether my graph will approach this asymptote and run up the face of it, or basically dive down in front of it on the left side and on the right side. Those are my only possibilities. I can't hit that line, my graph can't cross that line, and so it's going to either run down on one side or the other, or both possibly, or go up this way. That is to say that if I find values that are very close to x minus 3, x equals negative 3 here, then they will either be positive or negative. I don't have to worry about what the values are so much, just so much as are they going to be positive or negative. If they're positive, of course, if the y values are positive, then my graph would be going up. If the y values are negative, they'll be going down. And so what I'm going to do here is just basically test a value. And I can almost do this mentally, but I'll certainly write it out in this case. Something like negative 2.9, maybe be smart and go negative 2.99. So something that's quite close to negative 3 on one side and something that's very close to negative 3 on the other side. And again, all I'm really interested in is, are these values positive or negative? And so what I do is basically just put that value in here. Now, this is close to negative 3, so this is close to negative 18, and negative 18 minus 9 would be a negative value. And again, all I'm interested in is negative or positive, so I don't care what the actual numbers are. Certainly I could pick up a calculator and do this, but as the questions get more complex, just thinking in terms of negatives and positives will be better. In the denominator, negative 2.99 is smaller than 3, so when I add positive 3 to negative 2.99, I get a positive value. And so if I have a negative divided by a positive, that means I'm going to have a negative value as I approach from the side of negative 2.99. So from this side, I have a negative value. So that tells me basically this is part of my sketch, this is not. Now I can sort of see something developing here. We'll come back to it momentarily. With the other side here, f at negative 3.01, same basic idea. If I plug in, if I sort of look to see what happens in the numerator and denominator, negative 3.01, again, close to negative 18, minus 9, negative on top, pretty straightforward there. And then in the denominator, I have negative 3.01 plus 3. And of course, this is slightly larger, and so I will end up with a negative value in the denominator here as well. And a negative divided by a negative suggests that I will have positive values over on this side. So that is to say, that will be there, this will not. So we'll get this all out of the way. And we'll wait on that one. Now just sort of pointing out something here, you can sort of see, and this was completely unintentional, but it worked out nicely. As my graph starts to develop here, I can see that this is kind of looking strange and problematic. The only way my graph could come from here, hit this point and hit this point, is if it were to cross the x axes here a second time. I know that's not happening, and so something must be wrong with my y-intercept. And of course, if we go back to this question, we see 6x minus 9, 6 plus 9. I just copied it incorrectly. This should be a negative 9. This will be a negative 3. And in doing the question, I'm actually able to self-check to some extent because the graph just didn't make sense. Now, again, completely unintentional, but at least we can see that as the graph comes together, it should be fairly obvious that things are, or maybe in this case, aren't working perfectly. So, final step here. I'm looking to deal with the horizontal asymptote, or just determine and deal with the horizontal asymptote. And I've written here that the horizontal asymptote is determined by simplifying the highest degrees of our expression. Now we'll sort of look at that in a second to see if we can understand why. But basically, when I get, what my horizontal asymptote is a value that my graph approaches as my x values get extremely large out here or out here. So you're talking about numbers like 10 billion or negative 10 billion. And when you put those numbers into these expressions, these other values become completely insignificant, and for the sake of the horizontal asymptote, can actually be disregarded entirely. And this, the highest power of x in the numerator and the highest power of x in the denominator, will be the dominant values and those that actually matter in calculating the horizontal asymptote. Now, we'll sort of see if we can see that a little bit better by looking at an example here. So this is just an Excel spreadsheet, and all I've done in it is put in little parts of the equation. So this is the 6x minus 9, the x plus 3, and the actual calculation for f at x. And then these are values of 6x and x if we disregard the minus 9 and the plus 3. And if we look at when we put big values in here, something like 1,000, this value gets to 5991. This value is 6,000. So in this case, I've simply disregarded, so sort of line these up here. So those two are kind of equivalent to each other. Here I've simply disregarded the minus 9, and you can see that the numbers are fairly close. For these two values, I've disregarded the plus 3, and you can see that these values are fairly close. And of course, my actual result, which probably is the value that I'm most interested in, are also going to be fairly close. Now, this is not the case, of course, if I use small numbers. If I'm using a value like x being 2, this is 3, this is 12, obviously a very big difference. But again, when I start talking about extremely large numbers, whether negative or positive, the larger they get, the closer these values get to each other. Oh, sorry, the yellow ones obviously. Negative 600,009 and negative 600,000. And then, of course, negative almost 10,000 or 100,000 and actual 100,000. And then, of course, you can see here as well, these values get to be very, very close. And if I were to pick a number that was actually legitimately big, I think this will probably just crash my computer, but if I stretch these out, you will see that the values, again, closer and closer together, closer and closer together, and essentially 6 in both cases here. So what I'm trying to show there is that, again, the idea was for horizontal asymptotes, all I'm concerned about are extremely large values or extremely large negative values. Nothing else matters. And so these plus 9 or the minus 9 and the plus 3 become insignificant and no longer affect the question. So all that to say that my horizontal asymptote now is at 6. I can put this in at 1, 2, 3, 4, 5, 6, all the way up here. And now I've pretty much got my graph figured out. So this line up here, we established, let's do it in black actually. So this line up here, we established the graph must approach from this side. And because it's going to approach that value, for now, this is what we're going to assume is happening. Down here, same idea. We knew it was coming down here. It's got to come up and hit this one, and then way out here somewhere, it's going to approach that horizontal asymptote as well. Probably could have done a better job with that. And essentially, that is my graph.